Alright, so the first thing I had to do was get our aim down sight transition animation working properly for our first person mesh. I had implemented this previously, but just for the assault rifle. Just like for the assault rifle, I first had to make a single frame for first person aim down sight. All we need to do here is make sure the arm is lower than where our weapon will be when we enter the aim down sight state. If part of the arm ends up in the scope view, it doesn't matter because of our opacity mask system, but it's still good to get this as good as possible. From there, I just had to make a single animation for each weapon going from our placement frame at the hip to our aim down sight first person frame. The optics are all at different heights, so you might think that we need a different animation for each one, but I found it looks fine with one animation per weapon, so we'll stick with that. When I really scrutinized the animations, though, I found that the system I had made previously wasn't taking aim down sight time into account at all. The way I coded things up should have worked in theory, but for some reason, the hip to aim down sight animation played at the same speed no matter what value I plugged in for the play rate. The weirdest part about this was that the aim down sight to hip animation was speeding up or slowing down to match the aim down sight time. The two states were essentially identical, using the same animation just played in reverse, so this was very confusing for me to say the least. After hours of debugging what was happening, I finally resorted to deleting the misbehaving state and just remaking it exactly the same way. For whatever reason, everything worked perfectly after doing that. This is a perfect example of what to do when you're working with Unreal and you see a bug that makes no logical sense whatsoever. The first step is always to delete your project's binaries and intermediate folders, then regenerate the project files, and then rebuild the project from scratch. If that doesn't work, though, sometimes just deleting and quickly remaking the misbehaving blueprint, or in this case, state machine state, will magically fix the issue. While I would prefer knowing what the actual problem was, having it fix itself for some unknown reason is better than spending more time debugging. So once I had that sorted out, we then had to make aim down sight actually work for all our weapon and optic combinations. At the end of last week, aim down sight only worked at all for the ACOG sight on the assault rifle. Just equipping any other weapon optic combination would actually crash the project. The first step to making the other combinations work was to set the scope radius and optic meshes for all the different combinations. The scope radius was a trial and error thing, but the optic meshes turned out to be a bit more complicated. Once that data table was filled out properly, the next step was to place all of these sockets for every single optic combination. Each weapon already had a socket for the actual mesh of each of the six scope options, but some required a bit of repositioning. I then had to add the three sockets for each combination that it needs to perform the aim down sight logic we've implemented. The first socket is the camera socket, which tells us where to move the weapon to. We move the weapon such that when it enters the aim down sight state, the camera socket is positioned exactly where the camera is. Next comes the scope center socket, which is how our opacity mask system knows where to evaluate the scope radius from. I initially tried to make the camera and center sockets just be one socket, but found it was much better to be able to move both of them individually. Finally, we have the optic mesh placement socket, which allows us to translate, rotate, and scale our optic mesh however we need, such that it fits exactly into the optic we are using. So, in summary, we have six options, three sockets per option, and three different weapons. That makes 54 sockets I had to manually place very precisely so everything met my rigorous standards. There was no way around doing it manually for the assault rifle, because it was the first time I was aiming down with each scope. Once I did the 6 manual placements, though, I would never have to place the 5 scopes other than iron sights again, thanks to this handy Excel spreadsheet. Since the meshes for all the scope attachments other than the iron sights are the same for every weapon, all I had to do was find the differences in position between the 3 new sockets and the actual placement socket for each optic. From there, it was just making a new row for the new weapon's optic and applying the same distance adjustments that the assault rifle needed to look perfect. This saved me a ton of time because instead of manually placing everything, all I had to do was copy and paste the values from this spreadsheet. This also makes sure that the same optic will look the same when you aim down sight no matter which weapon you use, which would have been nearly impossible to do without the use of basic math that I've applied here. Since the iron sights are different per weapon, though, I unfortunately will have to place those manually every time I put a new weapon in. One manual placement is much less time consuming than 6, though, so I'll definitely take it. When I went to swap to a different weapon, though, I got a whole bunch of errors, even though all the expected sockets were there and the data table was filled out correctly. These errors were related to our dynamic material instances, which, as a reminder, are needed for the first person meshes of all locally controlled characters. The errors occurred because in the code, I was taking whatever material was currently applied to the mesh component and creating dynamic material instances from them. After the initial creation process with the default weapon, though, I was trying to create dynamic material instances from dynamic material instances, which is something that was a big logical error on my part. The fix I implemented was to explicitly set every weapon mesh back to its default materials after the swap took place. Once that was done, I went into my usual creation and application of the dynamic material instances. This worked well and will also help performance because the dynamic material instances from the last weapon could then be more quickly destroyed. This is because previously I was relying on the garbage collector versus manually destroying the old material instances once the new ones were applied. Once this issue was fixed, I had to give some attention to our optic meshes. If you remember from last time, we were just using a basic cylinder for the ACOG sight optic mesh. We could get away with this because the sight picture was a perfect circle. Unfortunately, though, the iron, reflex, and hollow sights are all not perfect circles. To fix this issue for reflex and hollow, I took the scope meshes into Blender and created the flat meshes you're seeing now that perfectly cover the sight pictures for the hollow and reflex sights, respectively. This worked pretty well, but I still had a big problem with the iron sights. Since the iron sights are basically 2 meshes combined into one, a front and a back, it made my opacity mask not do what I needed it to do. The whole point of the opacity mask was to clear the sight picture, but if I applied the mask normally, then the front part of the iron sights would get hidden by it. I could have implemented a material workaround to fix this, but I also found that in my trusty asset pack I have for the weapons, surprise, surprise, the iron sights aren't lined up correctly. When you align the camera perfectly with the back iron sight, the front iron sight isn't exactly in the center of your view. This would make aiming down sights with irons very disorienting and is definitely a deal breaker for me. Fortunately, though, I was able to work around both of these issues by letting the opacity mask hide the front iron sight entirely. I then went into Blender and created a mesh that was just the front iron sight. Once I had that mesh, all I had to do was use that for the optic mesh, and I could then place it so it perfectly lined up with the back iron sight. I then modified the material for the optic mesh version of the front iron sight, so it only shows up when we are in the aim down sight state. Once my unique optic meshes were all set, you can see that aim down sight works reasonably well with all of them. There is, however, a small issue that I will look into fixing later on. Our scope opacity mask system masks things out in a perfect circle, but as we established, these special cases aren't perfect circles. This makes these optics look a little bit weird in the aim down sight state. The best way I can think of fixing this is to modify the actual scope meshes so that their sight pictures are perfect circles. It would be easy for the hollow and reflex sight, but the iron sights would require a pretty substantial amount of 3D modeling for someone who tries to avoid it like the plague. Updating the opacity mask to mask out custom areas is something that I know is doable, but I feel like it would be a giant pain to pull off in practice. If the scopes were just another perfect shape instead of a circle, it would be relatively easy to do, but with their irregularity, it would be a giant pain to pull off. I have more pressing features to worry about for now, but addressing this issue is something I will punt to a future video. And with that, aim down sight was finally implemented after pretty close to a month of working on it. The next feature on my list thankfully ended up being much easier to implement. That feature was weapon sway. On the back end, I already had a weapon sway constant and weapon sway fractions and attachment multipliers that weren't doing anything as of now. Once I multiplied all these values by the frame rate, which is very important because we don't want the weapon swaying differently based on the frame rate, I had the radius I needed. The reason this value was a radius is because I believe that weapon sway should be a perfect circle. Some games implement sway in a random pattern, but I think it looks better being a circle that matches up with all of our animations. I also am a fan of increasing the skill gap wherever possible and rewarding players who learn to compensate for the fixed circular pattern instead of just randomly applying sway like so many games do. The math behind this is very simple, and everything we needed is covered by the end of your standard pre algebra course. I also set the cycle time and constant as blueprint editable, so I can tweak these values whenever very easily. I won't really know if this is enough or too much sway until I start playing the game, which is getting surprisingly close at this point. Speaking of that, we now have a character that can move around quite a bit as well as aim down sight. The next step will be implementing sliding and slide canceling, which is one of my favorite advanced movement techniques that have cropped up in first person shooters over the years. When I test things out, I definitely wish I could make use of this movement mode, so that's what we'll tackle this week. If I have time after that, I've decided to move on to reloading and firing next. We still have the prone, swim, fly, and parachute movement modes to implement, but those are ancillary in my opinion. I'd much rather get this to the point where I can play an actual game against bots, which should be doable in the near future. Speaking of the future, subscribe to the channel if you want to keep up with the development of creators. I post one of these videos every Sunday night at 8:30 p.m. Eastern, and I'd love to have you along for the ride of making my dream game a reality. Also, like the video because it heavily increases how many people YouTube will show this video to. I also have the Steam wishlist link in the description, so definitely check that out if you'd like to be notified when this game finally gets posted to Steam. Last but certainly not least of the housekeeping items here, please continue leaving comments on these videos. It's so great to hear from everyone about what they liked, what they didn't like, or other ideas for how to improve things. Also, feel free to just say hey down there because it's the best way to reach me at this point. With all that being said, though, my name is Steve. Thank you so much for watching, and I'll see you all next Sunday night. Have a great week, everybody.